Today, I am in Switzerland and I'm meeting with my friends here at Fraisa. One thing I've learned about this company is over 90 years of development, one thing is certain. You feel like a VIP or even a VIC, a very important company, when you work with Fraisa. Yes, you are that important. The development that goes into it, their one-on-one relationships, the fact that they study every tool for years and then give you that information so you don't have to try and just pick it from a catalog and try your best. Yes, we're gonna go through the entire facility to understand how these tools are made, how they're packaged and put together. We're even gonna talk a little bit to the people that are doing the R&D. We're gonna talk a little bit about production as well. The step-by-step process to help you understand exactly what Fraisa means for almost a full century. So join me inside where Stefan is waiting because I cannot wait to show you this unique, one-of-a-kind facility. Stefan!
Hey, wonderful,
How
Tony.
good to see you!
Hey, thank you very much. Great to have you here with Frasa.
I'm so excited. It's not every day we get to walk into a facility like this to see what the future of manufacturing looks like.
You are absolutely in the right place, Tony. I want to take you here in the production of our high precision tool. I will see there. We'll be fascinated what we're doing. I'm personally 20 years now developing here tools. Every day I'm still fascinated. Do with the team such a great products. So yes,
let's get started because 20 years, you are the right man for this camera work right now.
Absolutely.
For the audience, that's for sure. I'm already seeing what looks to be dozens and dozens of grinding machines, which is obviously the core of what you're doing here.
Absolutely. So metal carbide is our passion for precision. You see here, different tools, mostly different diameters, lengths, but more than the bigger ones here. So here it's going on really action and powerful grinding technology on those Rheinecker machines here. You see also how we produce those tools. First of all, there's always a rod, and then we have to put it in the machine, clamping system, and then we go with the grinding wheel in a slotting process. So the main material of the tool gets removed, and then finally we sharpening, we finishing also the front part of the tool. But you see all the other ones with a lot of teeth here, so finishing tools. We grind for such a tool here about 60 minutes, so an hour for one tool. There are other ones we are producing faster, but it's really different here.
You know, I come from, and let's continue to walk, I come from the machining world, and currently we discuss all the time, you know, done in ones and reducing cycle time.
Yep.
Are you doing the same thing inside of the grinding machines, putting in raw material and taking out a finished cutting tool and doing your very best to combine operations and take cycle times from say 30 minutes to 5 minutes? Are you doing all of that to make sure that you're getting your production, keeping up with the demands really, because you guys continue to grow globally?
Yeah, absolutely, it's important. We're standing here in the Switzerland production. So you know, the salary is the price to produce out of Switzerland. Most of our products go out in Europe, in the United States, in China. I have an international competition. Producing out from Switzerland is expensive. So for sure, we have to optimizing our process. Therefore, the automatization is really important. When you look in a machine like that, you see the robot still holding here, the rod prepared for its operation. Then at the back side, we see the different grinding wheel packages. For sure, we have optimized during the last year, not only the grinding strategy, also with the grinding wheels, with the metal bounded wheels that we can dress with EDM technology. So that's really important. And I look at those products here. This is a multifunctional tool. That's not so sharp, it's a steel end mill. So Tony, don't hesitate, I have sharper ones.
Good news, thank you.
Yeah, but I will show you that afterwards. The thing on a machine, also 6.3 times the diameter length of cut. So your machine in a whole cut, a workpiece. But what means that for us here? I have also to grind that really long cutting edge, so that takes a lot of time. and therefore it's really important that we are performant also with our grinding strategy.
Stefan, when I look at this tool and coming from a machinist background, I would certainly in my younger days hesitate to want to utilize this at full cut. But you would advise people to utilize the whole thing, wouldn't you?
Yep, absolutely.
And that goes into your strategies and quality as well.
Absolutely. The grinding part, Tony, is one thing. The developing before, that's then the whole story. To create a tool which is able to do that not only once, twice, every day. But what means that? I have to offer to the product also knowledge. How you have to do that, the strategy, the programming and all that. We will see that later. That's a main part of our intention, of Frasa intention. Giving it all, not only high performance products, giving also knowledge how to use the product.
Stefan, that is one of the major details I want to talk with you about on this tour, is the in-depth wisdom that you and your team have here that you provide to your customers. You have milling strategies. You don't just offer a cutting tool. I used to get cutting tools and have to figure it out on my own, but you offer milling strategies. Now, that's a segue we're going to talk about in just a minute, because I want to step back in conversation to the importance of automation. You've already pointed out the robots. I look around and I see them everywhere throughout the facility. I look around and I see a few people here, but a majority of those machines are running on their own.
Absolutely.
What do you think is the importance of automation here?
The importance of the automation is for sure once the infrastructure, but at the other hand also products that they can integrate in an automatization productivity production. So I still in the development have to think how I can produce this tool, in which tolerances I have to be really precise, where perhaps I have a little bit more possibilities to increase the tolerance. So focusing also in the production development, I would say that is really important. And at the other hand, we invest yearly a lot of time to make automatization better combined. You see here, for example, also our smart pallets. Perhaps we go over there, we will see that. So I know at the beginning of a production here with its smart pallet here, you see the RFID chip on it. So the tool rods, they get prepared before also with the robot in the smart pallet, and from the beginning on I know exactly this is this tool, this is this order here, the machine knows it, and finally this pallet goes until the end of the production with the tool. So that's also one part of automatization. And for sure you see here also the grinding wheels. The grinding wheel is such an important element of our production for the quality, for the wear on a grinding wheel, the stability of the process. So all those combined finally makes automation even more performant than we've got in the past.
Truly a great answer, Stefan. Thank you for sharing that. Let's slide over this direction. We have so much to see today.
Yeah.
And I want to go back to what I had segued to before, because when I think about Fraisa, I think about a company that started in 1934.
All right,
so we're over 90 years of development, and you guys pride yourselves on being the best. This quality product that from the design, from the automation, to the coding, which is so important, to being able to measure everything, because you can't make something if you can't measure something, right?
Absolutely.
And your philosophy, stepping back to what we brought up earlier, is you want to make sure that when people work with you, they have a full solution. You've created ability on your website to pick a tool and understand the tool and understand the process. It's not just about giving you a call and saying, hey man, I need a 10 millimeter tool and I'm cutting aluminum, or as we say in Europe, aluminium, right? But it's not, we're not doing that here. You are giving a full solution. Can you describe to the audience what 90 plus years of dedication to that understanding and partnership does for anyone who invests in a partnership with Fraisa?
Yes, thank you very much, Tony, to give this question. And so the basic of all that, as you said, is 90 years of experience and culture. For sure, we began with the technology, the tool technology, the performance. That is the base. So a tool has to work, and it has to work daily and annually, always on the same performance level. But as you said, that's not enough. The performance level is today so high. The question is always how we transfer this performance level to all our customers. So we have to give knowledge with it, and that we integrate in our tool expert, in our tool software. So therefore we invest also a lot of trials, of developments to do that. But finally we need also partners to create this whole story, this milling system. We need partners in the automatization, in the production technology, but also in the applications technology. We can't do that ourselves. And one part, most important part, it doesn't help if we are freaks and specialists herein. No, we have to transfer it to the market, and therefore our sales, our application engineers, daily by our customers, guiding them, helping them to implement those products on this quality and this performance, understanding what are the needs of the problems of those customers, helping them and giving us also feedback. So that's a sharing of knowledge, of culture, of willing to go together into the future. And that's what we are standing for. So we are really open to discuss always transparency, what is to do, where we want to go, where perhaps we have certain opportunities to work on. And then we go therein and always be also critical and validate us ourselves that we can guarantee quality. I can give you here, for example, this tool. This is now a high precision ball nose tool. It's not the precision one we do, but you see here the tolerance that we've got here. We are talking about microns here. So the radius of the tool is plus 3 micron minus 6 one, and look now here is measured it, and that's also a Frasa element. The tolerance of a ball nose here is over the whole nose, and you know when you two teeth, it's really difficult to part in the front of the tool. The guarding here, this tolerance, and look at that, how many measure points he produce here to hold exactly this tolerance. For our customers, it's so important that can get finally exactly this diameter, program it in a CAM program, and they know, yes, the mold finally is especially in this quality that I have to do. So that's also a service that we give with our products. For sure, the performance, the tool lifetime of the products has to be all of the state of its art, but here that's an additional one.
Something I want to slide into, because we're going to head in the general direction of grinding, and that's another one of your areas that's quite fascinating to me.
Yeah.
But along this journey, I want to talk a little bit about your eco-friendliness and your awareness of energy consumption.
Yeah.
Energy consumption has been an issue around the world over the last few years,
Yeah.
that they keep doubling, tripling, quadrupling the overall cost of energy. And it is very important to you guys here at Fraisa and some of the partners here in Switzerland to do everything you can to reduce costs. Would you mind describing what efforts you go into when you design a cutting tool of maybe reducing energy by 20% or 10% or 30%? And can you translate that for the audience so they understand exactly what that 20% means to maybe driving a car or something like that?
Yeah, great. Yeah, absolutely, Tony. Thank you very much. That's also a personal intention to reduce energy consumption. And we have still a lot of possibilities to do that. I can give you an example. I've developed a tool concept that we launched in 2023. It's named eCut for Alu, so aluminum machining. And the task there was to make a really smooth cutting tool, smoother than even all what we've get until now. Because in the past we always put a little bit more security, pressure, bigger rake angle on the tool, so that was okay. But with this new development, we reduced the consumption of spindle power 20%.
It's impressive.
It's impressive.
Yes.
It has to do with the rake angle, with the slot geometry, has to do with the grooves that are really smooth grinded. But what means that? Not 20% less energy consumption. Yes, you can drive with a car 19,000 kilometers when you take an old diameter can tool, that's only a small tool, and put in a new one. This tool, when it runs a year in a production, the saving of energy consumption is 19,000 kilometers, or you can heat a house 190 days, and for sure you can also save a lot of money. And additionally, you made a really good footprint also for the same work.
Yeah, very well said. We've made it to EDM. I'm just going to tack on to that. You've mentioned the energy consumption in a car, in a house, but we're also saving the lives of our machines, and how expensive can they be as well. But let's slide into EDM and this whole grinding wheel area. Now, you're far more familiar about this than I am, but I know that the concepts of machining a part and the concept of making a tool have a lot of similarities. You're constantly trying to multitask inside of a machine to create new geometries, as you mentioned, for eco-friendliness or for part production or for longer tool life. The industry that we're in right now, a lot of folks out there will probably agree with my statement, is that there's a constant competition between software, cutting tools, and machines. And at some point, the machines are ahead of the other parts, and sometimes the software is ahead. Currently, cutting tools are ahead of everyone. So everyone else is trying to catch up at the moment. So instead of making the coolest and best technology, what you are doing, you're really trying to figure out how to make these tools last longer and how to make more of them within a machine in a shorter amount of time. And that's the concept of this whole grinding area, isn't it?
Yeah, absolutely. The grinding wheel and the perfect dress grinding wheel is the base. So you saw all the machines there and the tools there. Without the grinding wheel,
they don't work.
Nothing has happened.
Right.
So therefore, also this department here is named the Grinding Wheel Competence Center. So the dressing of a grinding wheel, the quality of the grinding wheel is so important, because you want to hold this tolerance, as we saw before, those micron during the whole series of production of those end mills. And therefore, those specialists have special grinding wheels also developed with our partners. Also their partnership is important. We can't do that ourselves. We receive the grinding wheels, metal bound grinding wheels, or dual grain grinding wheels. This, for example, is something really special. This is a grinding wheel for a chip breaker. For a special chip breaker system that we developed. I will show you that afterwards on a machine.
Okay.
And I have also high-speed camera sequences showing you what is going on with such a chip breaker. But look at that. That is such a special form of this chip breaker. So the transitions of the chip breaker is so smooth. And we developed, I invested about 7 years. 7 years. I lost a lot of my lifetime years. But Tony, you know, we are all fascinated. So I invest that globally. But it's so interesting. You see here now a grinding wheel. You see it in a machine. And you will see then the result of the product on a machine. The customer that is satisfied, because the right chip length in an automated machine is elementary important, because otherwise you can't machine safely, because the whole table is filled up with chips. So you see now what means that a systemic development production and also story, sensible story, begins with a grinding wheel, ends then with a customer which is satisfied because his production can run automatically.
Amazing, amazing. All right, let's slide over this way, Stefan. As we slide into an area which I would lightly describe as the beginning of the end process, where we're starting to clean it, where we're starting to put on coatings, where we're starting to package it, and we're going to show all this. Would you mind describing to me your company culture here as well? Because you've recently won an award that I would describe as for the people, by the people, where there's actually an anonymous posting. And you know how mean people can be online when you have no disregard for anyone because you don't know where it's coming from, and yet you guys won that award because your culture here, you really take care of one another. Yeah,
absolutely. Look, you see a lot of machines, you see a lot of technology, but the core is still the human, the teamwork. I can't do that myself all alone. I need everyone setting up the cleaning process. For example, over there, look, this machine, this special developed cleaning process here with over 13 cleaning steps to guarantee that the tool is really well cleaned before we get up with the coating. So I need their partners, I need humans, and it goes then on finally in the reproduction, so that I can guarantee every day the same quality of performance. I need human. Also the measuring, I have to develop the measuring method also. I need people that can interpret also the results of what they're doing. And therefore we need also teamwork, transparency, but for sure we need also process. And that has a lot to do with culture, Tony. Be open, be transparent, talk about also what's not going on really well, but do that always in a manner of fairness and respect.
Very, very well said. I had to even take a moment of silence listening to you because I love the culture here. And you say it out loud, but I can see it in all the people around as well. Every time you walk into a room, people are smiling, working diligently. They look like they love their jobs. But let's segue a little bit from the culture and people to actually what the audience is looking at right now. And in this room, we can't touch a thing, can we? No fingers.
Absolutely.
Put your hands in your pockets, right?
You're absolutely right, Tony. So here all the colleagues are preparing the satellites to then finally apply our high performance coatings on a tool. So yeah, you look up them, they wear gloves here. So if you touch here a tool, even your fingerprint on a tool can damage a whole coating charge here that we're now going here in this room. So it's so delicate. You can't imagine how delicate it is when a tool isn't cleaned really precisely. You don't see here now a lot, but we are here in our coating department. You see different machines which are running, which are applying our coating recepts. So recept use several hours here now to put this coating on a tool, and the influence of a coating is incredible. So for the tool lifetime, for the performance, also for the reduction of energy consumption, because the modern coatings are so thin or so fine, that has a big influence of evacuation of the chips out of the tool. So we invest here our own development, for sure, also with partners, but that's here a core element of our production also.
Just for fun, if I was to take 100% of a process, what percent of that would you label the importance of the coating?
It's a really big one.
Yeah.
It's a really big one. For sure, we have the substrate, we have the geometry, and we have also the coating influence. So if you don't have a good raw material, as always, then you lose performance. But a coating is a main part, I would say. I can't say directly in a percentage. It depends also of the tool type, I would say, the machining material. But I would say could be in certain cases 50%. So really impressive, the influence of the coating.
And from the outside looking in, Stefan, when I think about a process that certainly you know more than I do, I mean 20 plus years, the company's been around for darn near, it's been over 90 years. I was gonna say darn near 100 at this point, and by the time some people watch this video, it might be, this video will live forever. But when I think about that, I think that geometry has been around a long time. There's a lot of mathematicians out there. There's a lot of science that goes into the certain angles that are presented to make the right cuts and the correct materials. But I almost feel like coating can be a secret sauce as well. Maybe that area is a piece of also why you're so globally successful and known as, if not the best, one of the best cutting tool companies in the world.
Yeah, you're absolutely right.
Is that a correct assumption?
Yeah, absolutely. Additionally, I can say that the geometry today is, there are still secrets. I'm developing, I'm searching on it. And we say always that the devil is in the detail. You have to go in the detail. You have to understand the detail. And therefore, we've got also here those measuring methods. I can measure that with a 3D scanner. I would say more macro geometries. I can compare them. But at the other hand, we've got here really precise measuring machines. I can measure here less than a micron, because I have technologies on the geometrical side today. They are elementary. Has an elementary influence, a supporting chamfer, for example, of a tool, which is really complicated to measure and to reproduce. And there the geometry is the big influence. On the other hand, when we are machining stainless steel, titanium, or nickel-based alloys, the coating is really important also. So I think important is to know for which application, which tool are the key elements. And we talked before about efficiency also in the production. So only always to make tolerances smaller is also not a good way. You have to know where it is important and where it isn't. So like there, we can also optimizing the production of tools.
This is why I bring people like you on camera, because you are the expert and we get to learn so much together.
Yeah.
So this is the quality department. We're going to head over to packaging, but I bet these guys would make the argument that they're the most important people here, right?
They're
quality
really
department. I see them smiling.
The most important.
They know the importance of what they do.
They're really
here.
important.
All right, packaging.
Yeah.
Man, I got to be honest. When I did packaging, I was doing it by hand.
Yeah.
You were not doing it by hand. You were doing everything within a system, and you're even being eco-friendly about that here as well. Can we walk through and describe the process here?
Yeah, absolutely. Lovely. Look at here, the tools are coming. They're now finished. They're coating. Look at the golden shining tools here that you're seeing. I think that's a diameter 3 or something like that. The tools get picked by the robot here, and they go now directly here in this part of the machine. That's the laser. The laser is putting on a unique number for every tool. So here I know finally this tool has its own number, and in 10 years when it's still in use, I can say, okay, it was produced on the 13th March here. And then it goes on through the station here. This one is now a little bit special one. He goes into the packaging here, the blue one, into the package, to close the package.
You know, I can, while we move on to this next section, I can move almost as quick as that robot. How about you? Yeah, well, I'm almost as quick. I could probably do close to the same. Obviously, I'm kidding. That thing is flying.
It's flying, so that's really fast, and he has to go to the restroom, and he doesn't stop in the evening. So he works on, and that's the big difference. Even if the robot is a little bit less faster than you, but he works. And Yeah, and that's also boring work. We're always saying here, Tony, the boring work has to do a robot.
Dull, dirty, dangerous, right?
Absolutely. And we have a lot of other stuff that still our good colleagues doing here.
So eco-friendly packaging, correct?
Absolutely. Absolutely friendly packaging, recycled packaging.
Well, it looks like we're getting to a completed product, which means if we're getting to a completed product, we're probably getting to the end of the tour as well, as you've taken us all the way through. And I see that when a product does get completed, all the data is collected from that as well.
Absolutely. All the data to every single product is now finally here also. Saved, stored in a database. But Tony, yeah, the product still here is finished. So the package here goes then finally on a stock. Our customer can order the product here.
Yeah, beautiful.
Well packaged, but it's not yet finished, Tony.
It looks finished. We made it to the end of the factory.
No.
What am I missing?
No, here it begins, Tony. Hey, what I want to do with the product sitting in a packaging, we have to machine with it. And what means that machining? Machining means also, Tony, that we need good employees, trained employees, new colleagues learning how to machine. You will see then that also CNC programming, you know it well.
A little bit.
Yeah, I know that you know it well. So we need knowledge, and therefore we have here our department building grow up new apprenticeship here.
One of my favorite topics, brother.
Yeah, I remember well in the 90s as I made my first CNC experience. And yeah, I think when you look at here, Tony, you see also conventional machining.
Which is how we learned,
yeah,
and we've kept it around.
Yeah, you feel there the chips. Here drilling and turning and milling, also conventional. This is important still, that you have the feeling what's going on, the forces, the temperature. Perhaps also the mechanics. What means that when I have to turn a wheel and the material sticks up or what else. So here those colleagues, they learn how to handle all that, and for sure also grinding competence, but also for sure CNC competence here.
Stefan, I think this is where we stop for now. But I think you have an entire machine shop that we have to dive into, don't you?
Absolutely, and that's my favorite day.
Oh, I love that too.
I like the production. That's necessary. But what's most beautiful than machining, making chips, understanding what's going on, and feeling the power that we invest such in it too. So Tony, I would say we go over there and go in our lab and then making some chips.
Absolutely, man. Let's go take a look. I'm very excited. Thank you for that. Thank you for watching. Stay tuned for that video as well. We're headed there right now. It feels like home. I tell you, the machine shop feels
here
like home.
Here we are, Tony. Yes. Welcome back. Great.
I'm so excited to film this video as well. R&D is one of my favorite topics because it's where we get to figure out what we're doing right and or wrong.
Yeah, it's important that you know both. It's also important that you know what's not good, because then you can prevent customers to set up those products. No elementary. You saw we produce those really nice tools. And yeah, without developing, it's not possible today. You can't develop a tool today on a green table, I would say, and put it in a standards in a catalog. That's not a good idea. So therefore, we invest here a lot of time only in this department, R&D. So means really strategic trials, really analytics. So not a lot playing all the days in the same manner. So that's really important.
Stefan, I want you to clarify a rumor for me.
No.
I've heard that you guys actually do R&D for 2 to 3 years into the future to make sure that all of these tests are done correctly before ever releasing something.
Yeah, absolutely. I'm finished.
That's true.
Yeah, that's true. I'm still finished now here, beginning of 25. The products for 26 That's still developed. I'm working on 27, 20, 28 developments now. It takes its time to understand. So a product I will show you afterwards on a machine there, I develop 12 to 24 mounts, and I make about 70 prototypes to define the product finally, to reproduce it, to know the technology. Because I've not only diameter 10, I've got it from 2 up to 20, from the short to the length. You saw the 6.3 times diameter over there, huh? So that means you have to test it, otherwise you're not gonna have a good feeling, put it on the market. You don't sleep well at night.
No, I couldn't imagine throwing something like that out into the wild and saying, good luck.
Yeah.
We think it works, but you go ahead and spend a lot of money on our tools and try it out for us. That's not how it works.
No.
Do you have a demo set up over here that we can take a look at?
Absolutely. Here are machines. They're machining a certain time. The tool is in action, and then after a while, after a time, we look on the wear. The wear analysis is still one of the most important. So for sure, you hear it, the noise. You can measure the consumption of power, force, and all that. But then, look at that now, 90 minutes machine in a construction steel here, which is not really easy to machine. You see the wear on a tool. Look how regular this wear is. You don't see a lot of addition here of material. So that's what we are doing. We're machining, we're comparing tools, we understand what is the influence of the geometry, has it to be positive or not. And I told you in the production, Tony, this chip breaking system for the automatization. So I've got here an example for you to show a little bit what means that. So what we are seeing here is a tool. And you see here a chip built in the front part of the slot and in the end of the part of the slot. And when you look on that, how the chip gets formed. So that's so impressive.
It is. It's incredibly impressive.
I have a fast camera to do that.
You must. I was thinking real time. Obviously, that's in jest and humor. That is a really powerful camera to be able to collect that data.
Absolutely, up to 200,000 pictures per second, Tony. So with a setup, really specialists can do that. So that's really helpful. You see a lot of things, but now look at that. The chip goes up in a one way, so it's a long chip. So therefore, I have to integrate a chip breaker, interrupting this process here, building the formation of a chip, and that is what we are seeing here on a second video. This is also a long tool in action, look at that, and then here you see then finally the chip breaker. Chip gets broken, a new building gets up, and like this we can cut the chip in several pieces. That makes it more efficient to remove it out of the workpiece, out of the table of the machine, doesn't interrupting the conveyor for the chip transportation. So technologies like that are really important to understand what's going on.
Would you say that recutting chips is one of the quickest ways to wear down a tool before anything else? That's why we're trying so often to either get coolant where it's supposed to be, use chip breakers, but regardless, we're trying to remove that material and get it out instead of rubbing or cutting the same chip twice and creating that dullness in our tools.
Yeah, for sure. That's for the cutting edge, once again, going through its own chip securely. That's also the reason that we integrate most of tools, those lubrication channels, and also the form of the chip. That's really important for a profile tool, for example. They can book their own chip, so that is then finally a really bad situation when a chip can't be removed. So yes, that's our part here, to thinking, looking of the chip formation, and really important. I will show you afterwards a photo you will love. I love chips, Tony. I even go diving into the chips because it's such an important part of our work here.
Perfect. Let's continue our tour R&D is so fun, and I would pay to see you dive into a bucket of chips, by
Yeah,
the
yeah.
way. Since you've already brought that up on camera, I'm gonna hold you to that.
Yeah.
We're gonna try and make that happen. All right, Stefan, I think of R&D, we're headed into production,
Yeah.
but along this journey, we've seen the production side of things, from you making the tools to utilizing the tools and testing the tools and packaging the tools and the automation, everything that goes in it. I've known you to be around for over 90 years now, and your dedication to your clients takes time, but gives results, and it's a long-term relationship that you continue to build. As a part of that, I've heard that you also do a retool. You make sure that if a customer invests in your high-quality product, that they can utilize it more than once. They can send it back to you, use it 2-3 times. Now, historically, when I was ordering tools, I always hesitated because I was told I was losing quality.
Yeah.
But I'm not losing quality with you. I might use a little diameter.
Yep.
But can you describe your retool process?
Yeah. Yes, Tony, that's a really important discussion here. You see, we invest such a lot of energy producing those tools. So, and therefore it's important that we can use this value that we invest several times. And therefore, it's an own part of the tool development that we develop also the retool, the resharpening at one hand, but also the recoating, the reproducing this 100% performance guarantee that we give to our customer. And yeah, we do that with our colleagues in Germany, where we making this retool process, and that we can guarantee this 100%. I'm absolutely with you, because the diameter is less, the stability can't be the same, the deflection of the tool.
That would have
I'm
been my
absolutely
question.
with you,
Yes.
with the same parameter. But you're absolutely right, we have to develop that. Also changing small elements. The tool doesn't look the same way, but it has to work on the same way, and therefore we make also validation. Every tool gets validated, and look at here, Tony, what I've prepared. This is an example of a validation. What we are seeing here. We see here 3 times the same operation. The first one is a diameter 10. This is now an MFC aluminum tool, really performant tool, and you see their different operations: roughing, high dynamic cutting, finishing, super finishing. And then we go into the next one, the 9.65. So there still, it's once regrinded, the diameter is less, and we test it with the same parameters, and we compare this performance. And then finally goes down to 9 millimeter, so means 10% of the core of the tool is less, and even then we can guarantee the same performance, the same quality. Look at those shining, bright surface quality that we reach. And that are we really proud. So that's for us a guarantee we give to our customer, and we test it also. That's not only something what we are telling, it's really something we're making seriously, testing, and then also finally guarantee to the customer this 100% performance guarantee of the retool.
Not only can I see your handsome face in the reflection of a super finish,
Yeah.
But I'm saving a bit of money as well by
Yeah,
utilizing this
absolutely.
process, aren't I?
Yeah, additionally. And that's a value that we're giving with our tool. So regrinding a tool makes then the price 30% less once again to a new one. So when you make then the total cost calculation, then finally you see that your price dramatically decreases, and the value is once again more really sensible, also economical, sensible. Yes.
And keeps the relationship going, I would imagine as well. If I'm gonna invest
Yeah.
in your product,
Yeah.
and I'm gonna invest in retool, which means I'm gonna stick around for a little while, right? you just showed me 2 to 3 opportunities for me to continue working with you. I'm saving money, I'm working with an amazing company, and I'm continuing to build that partnership. There's so many wins to the Retool program. All right, now we're in production, and these guys, I think they all want to be on camera because they love the camera so much.
So now we are in the freak department.
The freak department, is that what we're calling them?
That is one of the best, the stunning department. Here now comes the product to its presentation, and that's what we are doing.
Yeah, I would want to be a freak in here too, I gotta be honest.
You're always welcome.
Do you have any favorite projects here? As I look around, some of them just keep missing, and I don't know what's going on, but some of these are really cool, you know?
Look here, we machine here high-speed steel. There's a 66 Rockwell here.
Oh my gosh.
Yeah, we go through without, like butter, we go through it here. That's a high-speed steel coated.
That's incredible. That is a fun project.
Stuff like that here is also, this is the aiming device project we did also together with our partners, especially Regofix was also integrated here. So also Swiss project we've done, the Matterhorn. You have to visit, you know it?
I do. I've seen this at my friends at Regofix. In fact, they just made me a small version of this. Yeah,
you can increase it, decrease it as you want, but we machine also titanium. Oh, look at that. Look at the quality here, die mold. That's nothing polished. That's all machine.
Straight off of the machine, no polishing.
Straight up for the machine, no polishing.
Wow, impressive work. So I look here, and you've already mentioned several materials that you've plowed through with your cutting tools. So if we spin only slightly, I see a whole wall of material, which I would assume is your investment in the testing process to make sure you're testing in all the different materials.
Absolutely. In our tool expert, in the cutting data software, more than 10,000 materials are integrated there, and material comparison. How you want to build up this competence? I have to take up quickly here a titanium, a stainless steel. Here this is aero aluminum, for example. So I can take it out, take it on a machine, stainless steel here, for example, or here a block of titanium, making tests in it, understanding what's going on for sure. That is a huge cost component also. But for us it's so important that we are understanding what's going on, and finally then also helping our customer be more quicker, more safety in production process.
What I'm realizing is that there are a lot of theories out there. There are a lot of beliefs. There's a lot of scientists that say my geometry will do a certain thing. There's a lot of coatings that say my coating will do a certain thing. And you guys say, well, let's put it to the test. Let's see if that theory is real. And I like that.
That's it,
And then, on top of that, if I look over my right shoulder and I look to my left here, you're going live to make sure that everyone understands what you're working on and how they can embrace it also.
Absolutely. It doesn't help us when I'm the absolute profi specialist here and I can share the knowledge. Therefore, we invite hundreds of customers, or actually going on our notice catalog training here. So we train our colleagues. That is a product not still launched. So Tony exclusively here at the view on a new launch product, April. So we are really proud. It's an end mill only for soft steel, construction steel. Really difficult steel, the machine, because it's horrible what a shit is in its material there. You have to be strong on a cut with it. So plug and play here. Plug it in, play with it, it works, it pays off. That is important, and share this knowledge also. So therefore we invest also from the applications technology for all our products here, from the small one, micro end mills, for example, cylindrical ones, or this high dynamic cutting, and a strategy really interesting with highest volume, but also with a lot of challenge, I would say, for the tool side. Up to 60 Rockwell or here, yeah, you see a different range here of tools, and for every tool it's the same process.
Can I bring up something to you that's a curiosity of mine? And it's the fact that we all know that some of the wisest, most seasoned machinists that we've ever worked with are starting to retire. And there are, around the world, this idea that maybe we have a labor shortage or a skills gap. I would make the discussion that you guys here at Fraisa collecting all of this data, because it takes years and years and years to truly understand what a tool is supposed to sound like, what the vibration is supposed to be, how to utilize it economically. We've already talked about in other areas about the reduction to be eco-friendly, right? But it takes years. You guys are doing that for us. So if we have a struggle of bringing in these expert machinists, in time they'll become that. But in the meantime, you guys can be the experts for us in our machine shops. Am I correct in that thinking as well?
Yeah, absolutely. That's an opportunity, but it's also a threat, a trap. So, like always. So I think it's important that we share with our partner more and more in the future knowledge, and that we are understanding where goes this voyage. Is it going, as many says, in an automatic programming, feature-based machining, all that stuff? But nevertheless, we always need data, how it works well and how not. And yes, knowledge is a transformation going on there, and we want to help to hold and win new knowledge and transfer it to our customer, be in contact with them, and therefore also we observe what's going on. We collect our data through our tools, and hopefully in the future that will help us to give support also to our customers.
I appreciate you confirming my thought process, because you're so much wiser than I am.
Yeah.
But have you ever played the game I Spy? Like I spy something green, I spy with my little eye.
No, help me please.
Well, I spy on this table a tool that I think we discussed a little while ago that I was hesitant to utilize. But it looks like you're demoing it, and we're bringing this whole conversation full circle. Is this true?
Yeah,
did I spy correctly?
It's a long one. You spied, Tony. That is a really long cutting edge, up to 6.3 times the diameter. And look at that. He's now in action. And you said, no, that's not possible. You can machine with a tool like that, and it is possible, Tony. And this is now a roughing process with this high dynamic strategy here. And finally we can also then making finishing, and it's impressing. The tool then finally gets in a plunging. You have to show that when he has finished the outside contour in milling. Look now the chip breaker. Look the chip breaker. Look how small are the chips. Look how safety, they fly away from the workpiece. So that was not only marketing, this is really the story. And now we have a look on it.
What are we getting ready to see?
What's going on? Now he makes a small stop. Now he's ready. Now now comes the plunging.
And this is exactly what we discussed previously.
Yeah.
It's almost like we know what we're doing.
Yeah. We know what we are doing.
We know what we are doing. We
Yeah.
have a saying in the US that I'm not sure it's appropriate here in Switzerland, but when someone says you can't do that, we say, hold my beer. And then we do it. It's kind of like what you're doing here, isn't it?
Please be calm, lie back, have competence. And yes, Tony, we know we are here on a technical level really, really high. He changed now to the high dynamic cutting. Look the chips, how they come out. That is what I showed you before with the video. And yeah, it has to be with our culture that we are transparent. Also internally, that's the reason we're doing validation of that, what we are doing. can we hold that what we are doing? For sure, we learned also, Tony. Not always we had a hit on a market, and that's also important that we discuss critical and make a lesson learned, and coming step by step to this real story what we are working for day by day. And finally, the customer, like if in a call, hey, what's going on? That's working.
It's working.
So it's taking him by hand also for the future for new projects.
Well, let's slide right over here as we conclude this incredible tour. Personally, let me say thank you for allowing cameras in. It's not every day we get to come into this facility.
Yeah,
I see that every machine is running from R&D to your retool to production and testing to live streams and making sure everyone has equal opportunity to be educated by you at the same time. We have partnerships that are important. None of us can do this on our own. Are there any closing statements as my pockets have gotten real heavy today. I may or may not have snagged some of your stuff, but any closing statements that you'd like to say just in general about Fraisa, the company, the people, the products, and working with all the amazing companies out there as well to invite them to give you guys a try?
Yeah, thank you very much, Tony, for this wonderful feedback. That makes my heart really feeling good. And Tony, this is exactly what is the sense. So I go every day in the morning up, I go to work. What is the sense to do that? For long-term sense, that is making together a good story. Having partners makes a good feeling. Going together in the future makes sensible to invest such a lot of time of our life for that story. And that is my intention to do that day by day with my colleagues, with my partners, to create success, real success stories. And that is also our culture, that we go on in this process, and there is still a lot of potential. So I see still in the R&D a lot of potential. My buckets are filled with tasks, and I'm really happy and thankful that I can do that also in the future.
Would it be less manly of me if I cried from your passion?
Yes.
I mean, I'm an emotional person,
Yeah,
Stefan,
that's good.
and your passion, it gives me chills. It makes me want to, just one single tear though, one tear.
Great,
Thank
Tony.
you so
I'm
much for your
impressed.
time.
Thank you for all of
Yes,
that,
it's
Tony.
been
It was
such a pleasure. I
Yeah.
hope everyone that's watching has enjoyed this as much as I have. We've never brought cameras into this facility before, and Stefan has been so nice to Thomas and the entire team, to almost 100 years of success and innovation to make your machine shops run better. That's why we are here. And you can go live, you can learn more, you can spend time with Stefan just like I did. So we'll see you again soon, and thank you again for watching.
Thank you.